Here I am taking Cannizzaro reaction from carbonyl compounds and mechanism also. The reaction name is Cannizzaro reaction. Cannizzaro. This reaction occurs in aldehydes with without having any alpha hydrogen atoms in the presence of a strong base and gives one oxidized product and one reduced product. In a chemical reaction, both the oxidation and reduction taking place is called as redox reaction. In specific, it is called as a disproportionation reaction. So, in the Cannizzaro reaction, disproportionation reaction is taking place. Now, the statement is when aldehydes which are not having alpha hydrogens undergoes disproportionation reaction. Disproportionation reaction in the presence of a strong base. Strong base. To give one oxidized product, that is a sort of carboxylic acid and a alcohol. This is the statement of Cannizzaro reaction. Here the strong base sodium hydroxide or potassium hydroxide or calcium hydroxide and etc. Now we are taking an example to explain this statement. Aldehydes which are not having alpha hydrogens, it is the suitable example. This is an aldehyde, it does not contain any alpha hydrogen atoms and it is again reacting with another formaldehyde in the presence of a strong base, sodium hydroxide, concentrated sodium hydroxide. Out of these two aldehydes, one undergoes oxidation, another one undergoes reduction. Addition of oxygen taking place here, HCOONA. It is oxidized product, and another one undergoes reduction. Addition of hydrogens taking place here, CH3OH. Alcohol is the reduced product. Here it is oxidized product, it is reduced product. Both the reaction taking place in the same is called as disproportionation reaction. And I am explaining about alpha hydrogen in the carbonyl compounds. I am taking carbonyl compound. This is a carbonyl compound. It is aldehyde. This one ketone. In this carbonyl compound, this is the carbonyl carbon. Next to this carbon is labeled as alpha carbon. And this carbon contains 3 hydrogen atoms which are called as alpha hydrogen atoms. These 3 are alpha hydrogen atoms. Alpha hydrogens. So it is not suitable for the Cannizzaro reaction. It is suitable for aldol condensation reaction. For aldol condensation reaction, there is compulsory alpha hydrogens is required. For this ketone, 2 alpha carbons are there and having 3 plus 3 6 alpha hydrogens. It is also not suitable for this Cannizzaro reaction. So this, it does not give the Cannizzaro reaction. It also not giving the Cannizzaro reaction. Alpha aldehydes without aldehydes with no alpha hydrogens. I will give the examples for this one. Aldehydes with no alpha hydrogens. Already formaldehyde is taken here. Benzoaldehyde. Another example for aldehydes with no alpha hydrogen atom. And in one more example, heterocyclic compound having aldehyde group. This is also having no alpha hydrogen atom. These compounds are involved in the Cannizzaro reaction. Coming to mechanism of the Cannizzaro reaction. Now I am taking mechanism. Mechanism. The process of conversion of reactants into products is called as mechanism. I am explaining process of the reaction. Initially, the base is dissociated as Na plus and OH minus ions. Here, this is the nucleophile. This is nucleophile. Negatively charged species is called as nucleophile. For this mechanism, there are 3 steps. In step 1, nucleophile attacking taking place. Nucleophile attacks on carbonyl carbon. This carbon is called carbonyl carbon. Taking formaldehyde here, it is attacked by nucleophile. This nucleophile is attacked on the carbonyl carbon. Why? Specifically in this place, it is a electrophilic center. So these electrons are migrated to here and this oxygen acquires negative charge. O get negative, H already there, and OH is the new bond. COH bond formation is taking place. This compound is called as intermediate. Coming to second step. Step 2. In step 2, hydrate transfer is taking place. Hydrate means H minus. Hydrate shift is taking place. Between this intermediate and another molecule of formaldehyde. I am taking this intermediate here. O minus H, OH, and second molecule of formaldehyde. These electrons are involved in the bond formation between carbon and oxygen. Then C, carbon becomes pentavalent. So this hydrogen or this one goes along with their electrons as hydride, H minus. And these pi electrons migrated to this oxygen and oxygen getting negative charge. Double bond O. OH writing here, and the second molecule HCO minus H and H. Here it is formic acid. Formic acid. It is alkoxide ion. Alkoxide ion. Coming to third step. Step number 3. This is the final step. Here proton transfer is taking place. Proton H plus. H minus means hydride. H plus means proton. Proton transfer is taking place. Here I am writing formic acid here. HCOOH. By its original nature, it is acid. It giving the proton to other. So H plus ion donor is called as acid. So these electrons attracted by oxygen, it gains negative charge, it gains positive charge. This H plus is attacked at negative side, electron rich side. So HCO minus plus HCOH H. Alcohol is formed finally, and Na plus is writing here. So it is a sodium salt of carboxylic acid. Its name is sodium formate, and is methanol. It is methanol. So in this Cannizzaro reaction, 3 steps are involved. It is the first step. It is fast step, and second step is called a slow step. Slow step is the rate determining step. Rate determining step. By using this step, we have to calculate the rate of the reaction. And third step is also known as fast step. This is all about the Cannizzaro's reaction mechanism. Now, I am taking some other examples. Types of the Cannizzaro reaction by using some examples. First type 1. HCHO plus HCHO. In the presence of concentrated sodium hydroxide, it gives HCOONA, sodium formate, and CH3OH. Here, same molecules I have taken. This reaction is called self-Cannizzaro reaction. Self-Cannizzaro reaction, and these are 2 different molecules of formaldehyde. So it is called as intermolecular Cannizzaro reaction. Intermolecular Cannizzaro reaction. Type 2. Here one formaldehyde I am taking and one benzaldehyde. Both are not having any alpha hydrogen atoms. It is aliphatic and it is aromatic aldehyde. Both are reacting together in the presence of concentrated sodium hydroxide. Out of these 2 aldehydes, which one getting oxidation? Benzaldehyde or formaldehyde? It is decided by attacking of nucleophile. Nucleophile attacking based on depends on different factors. Attacking of nucleophile or rate of reaction is based on, it is directly proportional to positive charge on carbonyl carbon, means COO. If positive charge increases on carbonyl carbon, nucleophilic attack is easily, and it is inversely proportional to crowding on carbonyl carbon. If any crowding is present in the carbonyl carbon, nucleophile attack will be becomes difficult. It is directly proportional to presence of electron withdrawing group on carbonyl carbon, and it is inversely proportional to presence of electron donating group on carbonyl carbon. If electron withdrawing group is there, nucleophilic attack is much faster on this carbon. If electron donating is there, nucleophilic attack is becomes difficult. Okay, attacking of nucleophile is depends on these four factors. It is the attacking of nucleophile increases with positive charge on carbonyl carbon and decreases with crowding on carbonyl carbon, increases with the presence of electron withdrawing group on carbonyl carbon, and and decreases with the presence of electron donating group on carbonyl carbon. Here, which one is getting oxidized? So it is aliphatic. This carbonyl carbon having two hydrogens on both sides. These are less bulky groups when compared with the aromatic aldehyde. This carbonyl carbon having one bulky group, that is benzene ring, and one hydrogen. So nucleophile attacking here it becomes difficult. So the OH minus attacking here only. So it is converted into oxidized product, HCOO remaining converted into alcohol, CH2OH. In the Cannizzaro reaction, the products are one oxidized product, one reduced product. Less bulky group can oxidize and more bulky group is reduced. So this one is explained by this factor. It is related to this factor, second factor. Next, coming to third type. Here I am taking benzaldehyde and second benzaldehyde with electron donating group like NO2 at para position. It is electron withdrawing group. So here NO2 draws the electrons from the benzene ring, and carbon electrons also becomes more electrophilic in nature. So nucleophile attacking here only. This activates the electrophilic nature, increase the positive. So here this factor is related. So CHO, it is normal benzaldehyde without electron withdrawing group, it can reduce CH2OH. Benzyl alcohol is the product, and other one will be oxidized, COO NaOH using here. Sodium benzoate at concentration nitro. Para-nitro sodium benzoate is the product name. And last type. Here I am taking one benzaldehyde and second benzaldehyde with an electron donating group on para position. So it is electron donating group. Methyl is the electron pair donor. Here this methyl group donate the electrons to this benzene ring, and electron density increases and electrophilic nature will be decreases on this. So nucleophile attacking on this carbon becomes difficult. Whereas benzaldehyde comparatively is better than this to attacking of nucleophile. So this can oxidize, this will be reduced. COO and A. CH2OH due to the presence of this methyl group. So this is oxidized product and this one is reduced product. This is reduced product, this one is oxidized product. This is oxidized product, this one is reduced product. All these reactions are based on these factors only. Okay. Next, one other type is there, that is called intramolecular Cannizzaro reaction. That is the last reaction, last type. Intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction. CHO, single bond CHO, the compound name is glyoxal. It is reacting with sodium hydroxide, concentrated sodium hydroxide. One aldehyde converted into acid, and the second aldehyde is converted into alcohol. This is the product. Coming to mechanism. Here I am writing structure of glyoxal. In the first step, nucleophile attacking takes place on carbonyl carbon, and these electrons move towards more electronegative, that is oxygen. It acquires negative charge, C O minus and OH bond, and C double bond O and H. The first step, step 1, nucleophilic attacking takes place. In the second step, step 2, these electrons migrating here and involving in the bond formation. This hydrogen is removed as hydride to transfer this carbonyl carbon, and these electrons are migrated to oxygen and acquires negative charge. COH double bond O, C O minus H and new bond. Here hydride transfer is taking place. The second step, hydride transfer is taking place. Hydride ion, H minus ion. In the third step, step 3, proton transfer is taking place. Proton from acidic group is transferred into negative side. So these electrons migrating here, it acquires negative, hydrogen gaining positive, and it transferred to internal transfer to negative oxygen. C double bond O, O minus, C H, OH and H. Here Na plus is there, I am writing here this one. So same product obtained finally. Here. So total reaction occurring in the same molecule is called as intramolecular Cannizzaro reaction. The reaction occurs within the same molecule. Some rearrangements are there. This is called as intramolecular Cannizzaro reaction. This is all about Cannizzaro reaction. I have explained statement initially, and some examples and a mechanism also. Final conclusion is In Cannizzaro reaction, the products are two products. One is oxidized product, one is reduced product. The reactants are which are involved in the reaction is aldehydes. The condition is there should be no alpha hydrogen atom on the carbonyl compound. No alpha hydrogen atom gives Cannizzaro reaction. Alpha hydrogen atom gives aldol condensation reaction. So, thank you.